Hello guys, and welcome to another JAMB Chemistry class. Chemistry. And of course, in this class, we're going to be looking at the laws of chemical combination. So please, before we continue this class, I would like to oblige you to just click on the red subscribe button just below this video. The red subscribe button does not mean you are paying anything. It is actually very free to subscribe to this channel. The importance of subscribing is such that when we release any new video, you'll be notified. You'll be given a notification that a new video has been published so that you can follow us and you can learn with us. So please, that red subscribe button just below the video, just click on it and click on the pin notification so that whenever we will release any new content, you will be notified immediately. All right, so today we're looking at the laws of chemical combination. First of all, what is even chemical combination? So chemical combination, we also call them combination reactions. Combination reactions, we call them synthesis reaction. Synthesis reaction, they occur when two reactants or constituents combine to form what? A new product. So whenever two reactants or two constituents combine together to form what? A new product, then chemical combination has occurred. So to go back again, I'm saying that chemical combination is also called combination reaction or synthesis reaction, and they happen when two reactants or constituents combine to form a new product. So basically, what does laws of chemical combination try to tell us? They try to describe the fundamental laws of interacting atoms and molecules. The fundamental laws of interacting atoms and molecules. So this is what chemical combination tells us or tries to teach us. All right. So what else do we need to know here? What you need to know here is that there are 4 laws of chemical combination. There are 4 laws of chemical combination that form the basis of chemistry. There are 4 laws of chemical combination that form the basis of chemistry. And of course, they help to describe how chemical changes occur. The laws of chemical combination help to describe how chemical changes occur. And of course, those 4 laws are not far from the ones we are going to list immediately. And of course, please do not forget that this video tutorial is brought to you by the O3Schools JAMB app. It is being displayed on the screen right now. If you want to pass your exam fluently without any issues, if you want to get used to the JAMB CBT environment, if you want to participate in mock exams, you want to participate in a study mode, you want to participate in a practice mode, you want to participate in a mock mode, you want to participate in the UTME challenge to test your preparedness for examination, especially for JAMB examination, then the O3Schools JAMB app is your sure bet for success. So please, if you use that app very well and you practice all the questions on the app, because the app actually has all the past questions available and also has all the likely exam questions that you will see. So please do not joke with the app. Download it from Play Store. It is being displayed right now. It has this logo on Play Store. So look for O3Schools JAMB app, JAMB CBT practice, O3Schools JAMB app. Look for it, download it, activate it. Activation is just 2,500 naira for an app that has all the past questions for all subjects for just 2005 with all those wonderful features I've mentioned earlier. Then of course you know that it's just a chicken chain. 2,500 naira is what some of you used to eat in the afternoon for lunch, for dinner. You go out to spend up to 10,000 naira. You go out to buy. So please, for your exam, you do not try to be stingy. Please get your app, activate it. You are helping yourself, and of course, you're helping yourself to pass your JAMB exam once. So, like I said, there are 4 laws of chemical combination as they help to describe how chemical changes occur. So, the first one is the law of conservation of mass. Then of course, the second one is the law of definite proportion or constant, also called the constant composition. And of course, the third one is the law of reciprocal proportion. Reciprocal proportion. And the fourth law is the law of multiple proportion. So these four laws, they help to describe how chemical changes occur. You must know all of them because they are very, very, very important, right? The law of conservation of mass, the law of definite proportion or constant composition, the law of reciprocal proportion, and the law of multiple proportion. All right, so now let's continue from where we are. If you think this video tutorial is too slow for you, please, there's a space there to what to increase the speed. If you think it's too fast for you, there's a place there to reduce the speed. So right, so please follow up and understand very well. All right, now I'm going to start with the very first law, the law of conservation of mass. The law of conservation of mass said that matter can neither be created. It said that what matter can neither be created nor destroyed but can be transformed from one form to the other. So the law of conservation of mass states that matter can neither be destroyed, it can neither be created nor destroyed. It can be transformed. It can be transformed from what, from one form to the what, to the other. That means changes in matter can occur, right? But matter itself can neither be what, created nor destroyed. This law was stated by Antoine Lavoisier. This law was stated by Antoine Lavoisier in the year 1789. So you must know who first quoted this law. Antoine Lavoisier first quoted this law in 1789. It's very easy. Matter can neither be created nor destroyed. It can be transformed from one form to the other. For example, if 2 grams of hydrogen combine with 16 grams of oxygen, if 2 grams of hydrogen combine with 16 grams of oxygen to give you 18 grams of steam, that is water now, then of course you see that what this is in accordance with the what, with the law of conservation of mass. We say that what matter can neither be created nor destroyed, but can be transformed from what, from one form to the what, to the other. And this forms the basis of all chemical reaction. The law of conservation of mass forms the basis of all chemical reaction, and this is why it is very, very important to know and understand this law. All right, so this is the law of conservation of mass, and this is what it is telling you. And of course, as I said, Antoine Lavoisier in 1789 was the first person to quote what, this law. All right, so now we'll go to the second law of chemical combination, and that law is, of course, the law of definite proportion or constant composition. So let's see, law of definite proportion, also called the law of what, constant composition. All right, so what is this law talking about? This law, first of all, was quoted by Joseph Louis Prout. This law was first quoted by Joseph Louis Prout in the year 1797. All right. So this law was first quoted by Joseph Louis Prout in the year 1797. And what did the law say? It said that all pure samples of a particular chemical substance will contain the same element. Let me write it out so that you get it very clearly. Let me write it out so that you understand it very well. Say that with all pure samples of a particular chemical substance will contain the same elements combined or bound in the same proportion by mass. So the law of definite proportion as stated by Joseph Louis Prout in 1797 said that all pure samples, the underlying word here is pure, all pure samples of a particular chemical substance will contain the same elements, of course, combined or bound in the same proportion by mass. A very, very, very simple definition. So, what is this law telling us about? That is to say that all pure samples, for example, of water, all pure samples of water in Nigeria, in Delta States, in Afghanistan, in the United Kingdom, in the United States, wherever you are on the face of this planet, all pure samples of water will contain what? What are the elements containing water? That is what? Hydrogen and what? And oxygen. So long as it is pure, it will contain what? Hydrogen and oxygen. And of course, they will be bound in the same proportion. 11.1% of hydrogen. This is the percentage composition in H2O, right? And of course, 89.9% of oxygen. Now, we are saying that all pure samples of water, for example, now of a particular chemical substance that is water, will contain the same element, that is hydrogen and oxygen, bound by the same proportion by mass. That is to say, wherever you are, whether you are in London, whether you are in Africa, whether you are in Asia, all pure samples of water, for example, will contain the same element, hydrogen and oxygen. Wherever you are, these are the elements that will always be present in pure sample of water, hydrogen and oxygen, and in this proportion by mass. Now, note that this will only hold if the samples are what? They are pure. It will only hold if the samples are pure. Now, another thing is, if different pure samples of a particular chemical substance, different pure samples of a particular chemical substance are produced by different methods. Let me write them out. Write that out. Okay, there's no need to write that out. Just note now. Just understand and follow me. What I'm saying is, if different pure samples of a particular chemical substance, different pure samples of a particular chemical substance are produced by different method. Let's say when water is to be made now, and of course, pure water is to be made, and of course, there are seven. Let's say there are seven methods for making water. This is just an example. Let's say there are seven methods for making water. Now, if you use these seven methods to what? To produce what? This particular chemical substance called water, right? Irrespective of the method you use, right? It will contain the same what? Proportion by mass constituent. That means that what is going to have what? This composition, and also going to have what? This what? Elements. So this is what the law of definite proportion is telling you, that all pure samples of a particular chemical substance will contain the same element combined or bound in the same proportion by mass, in the same proportion by mass, as I've stated here. So please just understand the law. The law is not difficult to understand. It is very what easy. All right. So that's what brings us to an end to the law of definite proportion or constant composition. And of course, now we now go to the third law of chemical combination, and that is the law of reciprocal proportion, as stated by Jeremiah Benjamin Richard in the year 1792. So that is called the law of reciprocal proportion. Let's see. Law of reciprocal proportion. Now, this law of reciprocal proportion, like I said, was stated by what? Jeremiah Benjamin Richard in the year 1792. All right. So this law was stated by Jeremiah Benjamin Richard in the year 1792. And what does the law state? The law states that if two elements combine with the same weight of a third element, and write that out. If two different elements, right, combine with the same weight of the third element, then the ratio of the masses in which they do so will be the same, or some simple multiple ratios, or some simple multiple of the mass ratio in which they combine with each other. Now I can see that the law seems to be very long, but I seem to understand the law more than I can write out the definition. But of course, if you understand the law, you cannot translate, because if you see the way the law is crafted, it's just in a way, it's just like as if they're explaining what the law, right? It seems like they're explaining the law. It's not like they're actually quoting it verbatim, like the way we say law of conservation of mass, right? Of course, so they say two different elements combine with the same weight of the third element. So two different elements are combining with the same weight of what? Of the third element, right? Then the ratio of the masses in which they combine, right? In which they do so will be the same, or some simple multiples of the mass ratio in which what they combine with each other. Now, what do we need to note here? Right? We say that the ratio of the masses in which they do so will be the same, or some simple multiples of the mass ratio. So the ratio, look at now, the ratio of the masses, and here I'm talking about what the mass ratio in which what they combine together. Those are the vital points in this definition, in this law. They said that if two different elements combine with the same weight of the third element, then the ratio of the masses in which they do so will be the same, or simple multiples of the mass ratio in which they combine with each other. A very typical example of this is sulfur and oxygen. If sulfur and oxygen, for example, combine with copper, we are going to have what? Two compounds will be formed, right? Just know that if sulfur and oxygen combine with what? With copper, Cu. Copper can combine with what? With sulfur to give you what? Copper sulfide. All right. And of course, if you see the ratio here is what? The mass ratio of what? Copper here is what? 64. Then the ratio of what? Sulfur here is what? Is 32. So this is what? 64 ratio what? Ratio 32. All right. Of course, still, copper can also react with oxygen to give you what? Copper oxide. So I want to have CuO. And of course, what the ratio here is what? 64 ratio what? 16. Now, the ratio of the masses, the ratio of the masses of the ratio of S and O, right? The ratio of S and O, the ratio of S here is what is 32. The ratio of oxygen here is what is 16. The ratio of the masses, that's the ratio of S and O, that is what? Ratio of what? S and O, their ratio is what? Is what? 32. What is ratio? What is sorry, the atomic mass of oxygen ratio what? Sorry, ratio 16. Right. If you reduce this ratio further, I want to have what? 2 ratio what? Ratio 1. The ratio of their masses, the ratio of their masses, which is 2 ratio 1, right? And of course, sulfur and oxygen can also combine with each other. Are you getting me now? Now, sulfur combined with copper to give you this. Copper combines with oxygen to give you this, right? Copper oxide. Now, sulfur, the ratio of the masses of S and O that combine with a fixed mass of copper. Fixed mass of copper here is what is 64 grams. So the ratio of S and O that combine with a fixed mass of copper, which is 64 grams, is what? Is 2 ratio 1. But another thing we need to know here is that sulfur and oxygen can react to form what? Sulfur what? 4 oxide, that's SO2. So when sulfur reacts with oxygen, sulfur 4 oxide is formed. And of course, what is the ratio of their masses here? Their mass ratio of what? Sulfur is 32, then oxygen is also what? 32, and this is what 1 ratio 1. Now, what that tells me that the ratio of the masses in which they do so will be the same, or some simple what? Multiples, or some simple multiples of the mass ratio in which they combine with each other. If you compare this, the ratio of their masses here, S and O here, is 2 ratio 1. But if you see the ratio of the mass ratio in which they combine together is what? Is 1 ratio 1. It's either what? You can say that it's just what? A multiple. 2 ratio 1 and 1 ratio 1. If you find the ratio of their mass of their ratio, you find the ratio of their ratio, that is ratio of this and this, that I want to have 2 ratio 1 divided by 1 ratio 1. That's of course this means 2 over 1. If you know mathematics, it means 2 over 1 times 1 over 1. That is what? 2 ratio 1. Of course, you see that what is just what? A multiple, a simple multiple of the ratio in which what they combine together. So this law was stated by Jeremiah Benjamin Richard in 1792. And of course, what you just need to understand is two different elements combining with what? With a fixed mass of the third element, right? Now, S and O combine with a fixed mass of copper. And of course, you see that the ratio in which they combine, the ratio of their masses, S and O is 32 ratio 16, but the ratio in which they combine together is what? 1 ratio 1. So if you find the ratio of the ratios we're talking about now, of course, I'm going to see that it's just a simple multiple. It's just a simple multiple of what? Of the ratios in which what they combine with each other. And this is in accordance with the law of reciprocal proportion. So we now move to the last law of chemical combination. And that law is, of course, the law of multiple proportion. The law of multiple proportion. All right, so law of multiple proportion. This law, of course, was stated by John Dalton in 1803. All right, so you need to note who was quoted that law first. That is John Dalton in the year 1803. And the law states that if two elements combine to form more than one compound, then the various masses of the elements that combine separately with a fixed mass of the order are in simple multiple ratios. Now, this is the law of multiple proportions stated by John Dalton in 1803. And what's saying that if two elements combine to form more than one compound, right? Then the various masses of the elements that combine separately with a fixed mass of the other are in simple multiple ratios. A very good example of this is sulfur and oxygen. Sulfur can combine with oxygen to form more than one compound. We can have what? Sulfur 4 oxide SO2 and sulfur 6 oxide SO3. So these are the two compounds that what sulfur can combine with oxygen with to form. Now, more than one compound, SO2 is a different compound from what? From SO3. All right. So now, if you see the mass of what sulfur in both compounds is fixed. The mass of sulfur is fixed. Sulfur is what the mass is fixed. For the sulfur, the mass is what is fixed, and it's what 32, isn't it? As you can see here, yes 32, yes 32. But the mass of what oxygen here is not fixed. For here, the mass of oxygen here is what is 32, but the mass of oxygen in what in SO3 is what is 48. So if you see the ratio in which they combine, if you reduce this, you're going to have what 2:3, right? This is 2:3. If you see the ratio in which what they combine with each other is what is in simple multiple ratio. It is not a fraction. It's not a fraction. It does not give you a decimal. Does not give you a fraction. Instead, this is what whole numbers, and that is what the law of multiple proportion is talking about. State that if two elements combine to form more than one compound, then the various masses of the elements that combine separately with the fixed mass of the other element are in simple multiple ratios. And of course, they bring an end to the class laws of chemical combination. A very interesting topic, you may say, but of course, it takes your understanding to fully grasp what the topic is talking about. Some of these laws are very, very important to understand, so that when we get to stoichiometry, to be very, very easy to understand also. So please do not forget to like this video. Do not forget to subscribe to this channel. Do not forget to share this video to your friends and colleagues so they can also learn and follow. Download the O3Schools JAMB app and of course activate it. And I'll see you in the next class.